Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the Clausen-Ester condensation, right? Clausen-Ester condensation. So look at what we are going to learn today, the remaining Clausen-Ester condensation reaction. As I already told you that this Clausen-Ester condensation reaction and the aldol condensation reaction has some similarities. The similarity, but in aldol condensation, the substrate or the starting material are the what we can call it as a carbonyl compound, like as aldehyde or the ketone. In those compound, the reactions are taking place. There are the three kinds of the reaction or three sort of the reactions, like as a simple aldol condensation reaction, cross aldol condensation reaction and the intramolecular aldol condensation reaction. Similarly here also, but here in the Clausen-Ester condensation reaction and this the Clausen-Ester condensation reaction, there is a word is ester. Ester means what? Yesterday we already discussed that ester means ester groups are there. An organic compound having a general formula RC double bond O R dash is known as a ester. And here the criteria for reaction to occur is the ester must have at least 2 alpha hydrogen atom, then and then the Clausen-Ester condensation reaction takes place. And yesterday we have discussed the simple Clausen-Ester condensation reaction. In simple Clausen-Ester condensation reaction required starting 2 molecule, 2 ester must be one and the same molecule. And for example, yesterday we have seen 2 moles of the ethyl acetate undergoes in presence of sodium ethoxide gives the product. The name of that product is a very versatile reagent obtained, which is known as a beta keto ester, or it is known as acetoacetic ester, or beta keto or acetoacetic ester or ethyl acetoacetate. And this is a versatile reagent. Versatile means what? Variety of the organic compound we can synthesize by using that ethyl acetoacetate. That we will learn how what are the application of that ethyl acetoacetate shortly in our maybe as in our next lecture. So but here remember how it is prepared by using as a simple with the suitable example. We have learned this simple Clausen-Ester condensation reaction, and today we are going to learn the crossed Clausen-Ester condensation. Here we are going to learn crossed Clausen-Ester condensation. Clausen-Ester condensation. This is the reaction we are going to learn. What is that? Look at again here, crossed Clausen-Ester condensation. Crossed means what? The reaction going to take place between as a 2 different ester molecule. Remember, 2 different ester molecule similar to as a aldol condensation reaction. The at least one of them must have 2 alpha hydrogen atom, and then the resulting product we are getting higher yielding product, because one of them the alpha hydrogen atom there, this require formation of the carbanium by using as a sodium acetate or the sodamide. These are the strong base are employed or used in this reaction. The aim or the function of these strong bases to abstract the more acidic proton, and as we know that there are the four methods to generate the Carbanion, and one of them is a additional adjacent to the carbonyl atom, whatever hydrogen atoms are present, they are highly acidic in nature. By using as a base, we can easily generate, we can easily produce the Carbanion, and once that Carbanion is formed, they can act as a nucleophile, and as we know that nucleophile, they can form as a bond with that carbon. Covalent bonds are formed, means new carbon-carbon bond are formed. New carbon-carbon bond are formed, it means that there is a synthesis, there is a new compounds are generated, new compounds are produced. So that is the synthetically, as far as organic chemistry is concerned, these reactions are very, very important as a synthetic point of view is concerned for the organic chemistry, and that's why we are studying the first chapter. Is the name itself suggests that Carbanion and their reaction. In this particular chapter, we are going to learn the four famous named reaction. One of we already discussed, second is right now is we are discussing, and third one, fourth one. First one is a aldol condensation reaction, second one is a Clausen ester condensation reaction, third one is a Perkin condensation reaction, and fourth one is a Wittig reaction. So these are the four named reactions. These are very, very important as far as a synthetic point of view is concerned, and that's why we are studying at this level, at T.Y.B.Sc level, these reactions. So let us cross the Clausen ester condensation. First, let me take as a first compound. Suppose we have this one. Suppose CH3 C double bond OET. That, and as I already told you that ET means what? This is a ethyl group. Means CH2 CH3 group is referred as a E2, or sometimes this group is maybe written as a C2H5. This is nothing but as a this one. These are the various ways to represent, these are the different ways to represent ethyl group in the organic chemistry. And some let us see here CH3 C double bond OA. This is called as a ethyl acetate. This is known as a ethyl acetate. It is a one of the molecule, and another molecule I am going to take over here maybe as a format H C double bond OET. That is a ethyl format. This is known as a ethyl format. Ethyl format. So this is another two different compounds are there, and out of that I already told that synthetically the one must have a alpha, at least two alpha hydrogen atom, then and then crossed Clausen ester condensation reactions are occur. Otherwise it is there will be a no reaction. Remember, one molecule is a ethyl acetate I have taken over here, and second one is a ethyl format, that is another molecule, and this molecule I am treating with the strong acid like as a sodium acid, that is a sodium ethoxide, which is a strong base. And what it will do, it will generate, it will form the Carbanion, and that Carbanion is going to attack over there, and you are going to get over here, I think this one C double bond O, then CH2, then C double bond O ET, that is a beta keto ester, that type of the compound we are going to get. And here remember, this is called as a reactive methylene group. Why it is referred as a reactive methylene group? The reason behind it I already explained you yesterday, but let me tell you again, because this is a present in between as a two flanked carbonyl group, means on both sides electron withdrawing groups are present, and therefore these protons are highly acidic in nature, and whenever we are using as a base, there is a generation of carbanion, and that carbanion you can further treated with the alkyl halide, resulting into the substitution reaction. So that type of the thing you occur. So this is called as a cross Clausen ester condensation reaction. Now let us see the mechanism, because we don't know how we are getting as a this type of the compound. For that, let us look at as a mechanism. Mechanism yesterday we have seen related to as a Clausen ester, simple Clausen ester condensation. But here let us see here this one, because this ethyl acetate has alpha hydrogen atom, and therefore alpha hydrogen atom required for the generation of the carbanion. Now look at here, C double bond OET, that sodium ethoxide means Et O minus, it will abstract the proton from here, resulting into as a formation of the carbanion like this. So that you in the step number first, what is going to happen? Generation of the carbanion, CH2 minus over there, C double bond OET, and further what is going to happen? That carbanion is well stabilized due to the resonating effect. This carbanion form double bond over there, and negative charge generate or coming on that oxygen atom, C double bond O, C O minus, negative charge and OET. And when carbon-carbon double bond adjacent to that negative charge on oxygen atom, these species have a special name. What is that name? Enolate. This species is known as a enolate. This is a special name is given to that species. Now in the step number second, what is going to happen? They let us take the another molecule of that ester, that is a ethyl formate, HC double bond OET. Now for sake of convenience, or to represent, to show the clarity of the mechanism, I am showing the molecule like this. Then that enolate CH2 here plus, then double bond C O minus, then OET. Now what is happening over here? Negative charge coming down, forming double bond between this carbon atom and oxygen atom. This double bond is attacking on this carbonyl carbon, and then what is going to happen? Yes, this you have to show over here. Now here H, then C O minus, and then OET is there, and then here CH2, then next one is a C double bond O and OET. Now in the step number third, what is going to happen in step number third? Observe this reaction carefully. I am writing this molecule as it is over here, like this here, H C O minus and OET. Look at here, O minus and OET, both the functional group, if present in the same carbon atom, that position is known as a geminal position, and that geminal positions are highly unstable, and therefore what is going to happen here? CH2 C double bond O and OET. Now this negative charge coming down, forming the double bond, at the same time it is pushing OET, that is a good living group. It leaves that here, and we are going to get the product is a H, C double bond O, CH2, C double bond O and OET. So this is the product we have got over here is nothing but as a, this is called as a crossed, what we can call it as a crossed Clausen ester condensation, right? So this is the reaction we have seen over here. Now let us look at as a some other example. Now you predict the product, what type of the product, whether you are able to predict that product or not. Let me see over here. Now let us see some of the example. From that we can get the clear cut idea regarding predicting the product. Once you know the mechanism, it is very easy to predict the product. Now let us see over here. Suppose I have a starting compound, this one, ethyl benzoate C double bond O, OAT. That is the compound I have taken. The name of this compound is a ethyl benzoate. Ethyl benzoate. Last suffix is a AAT, indicate as a ester group is there, and now it will be treated with this one, same CS3 C double bond O, then OET, which is you know that the name of this compound is a ethyl acetate. The name of this compound is ethyl acetate, right? Ethyl acetate, and these two molecules, the substrate I am treating with strong acid like as a sodium ethoxide, and what kind of the product I am going to get over here? I am going to get the product is this one. Let us see over there, C double bond O, then CH2, C double bond O and OET. This is alpha beta, this is a beta keto ester. I am always end upping with the product is like this. So there is a reactive methylene group or 1,2-dione it is called, or beta diketone, and it is a versatile synthon. Variety of the organic compound we can prepare from this, and that's why it is a very, very important as a synthetic point of view is concerned. So this is there, and if you see the mechanism as we already discussed that how form the carbanion over there, and this carbanion is going to attack over there, then OAT get removed and you are going to get as a product is this one. In short, how we can show as a mechanism, let's see over here, CH2H, then C double bond O, OET. I am showing as a mechanism that could be, so OET minus, which will abstract the proton from here, negative charge forming here, CH2 minus charge, C double bond O, and OET plus, not plus, there is a resonating delocalized arrow. Delocalized arrow means what? You can draw the same structure in two different ways. So that is the meaning of this arrow. Delocalized arrow always shown by the double headed arrow, and therefore this negative charge coming over there, and this is known as the here this species means carbon carry as a negative charge is known as a carbanion, and therefore this carbanion, what is going to happen? You are going to get here CH2 double bond CO minus and OET here like that, and this species is known as a enolate, right? And this enolate further treated with the acid, I am writing in short, C double bond O, OET, right? Like this, and this negative charge coming here forming as a double bond, and this double bond is going to attack on this carbonyl carbon, and this double bond revolving around it and OET get eliminated, and finally you are going to get the product, this one pH, C double bond O, then CH2, C double bond O and ET. This is one of the simplest way to represent the mechanism of this cross aldol condensation, right? This is all about the cross aldol condensation reaction, or we can take as another example of this cross aldol condensation reaction, and now you can draw the, or you can predict the product. Now you are very much able to predict the product because you know the mechanism now. Now only I am writing CH3, C double bond O, OET, and then here ETO, C double bond O and OET, and then that will be treated with sodium ethoxide. Look at there. Is this cross aldol condensation reaction possible here, or the reaction will take place? Yes, there will be this will be a cross Clausen ester condensation reaction. Look at here, there is a ester group, here also has a ester group, and therefore this reaction ethyl carbonate, this one is called as the ethyl carbonate. So this is the name of this compound, and this one, as you know, that this is a ethyl what is that, ethyl acetate. And now this ethyl acetate, what is going to happen, these two are a different molecule, and therefore you are going to end up with the single product, single adduct, and with higher yield, because this product is going to get here in the same how the product will be this one. I think here you can write ETO, then C double bond O, then CH2, C double bond O, and OET. This type of the malonic ester you are going to get over here. Look at here, this is a ester group, this is a ester group, middle one is a CH2, and this one is known as a malonic ester or ethyl formyl acetate, or this is a malonic ester we have got over here, because this ethyl acetate then form as a carbanion, and then it is going to attack over there OAT loss, and finally we will get as a this type of the compound. So this all about the what we can call it as a cross Clausen ester condensation reaction. I think you are not I think you are now able to predict the product of cross aldol condensation reaction, or maybe as a simple aldol condensation reaction. Is there any is there a need to give more example? I don't think these are the enough example to understand the concept of cross Clausen ester reaction, and synthetically it is very useful as far as organic chemistry is concerned. Now I think, and last one is that is called as a Dicmonocyclization reaction, right? Dicmonocyclization reaction, or we can call it as a intramolecular intramolecular Clausen ester condensation reaction. That reaction is called as a Dicmonocyclization. Dicmonocyclization, it is one of the important reaction. I think D-I-E-C-K, Dicmonocyclization. D-I-E-C-K, Dicmonocyclization. This is nothing but as a intramolecular Clausen ester condensation. Dicmonocyclization is nothing but as a intramolecular Clausen ester condensation reaction. This is you have to remember over there. When the two ester group are the part of one and the same molecule, or intramolecular Clausen ester condensation takes place, giving 5, 6 or 7 membered cyclic beta keto ester. This is called as Dicmonocyclization or Dicmonocyclization, whatever pronouns you because whatever pronouns you feel is good, you can pronounce it. That is a Dicmonocyclization. Specifically, it is nothing but as a intramolecular Clausen ester condensation reaction, means the same that ester groups are present in the same molecule, and therefore that type of the compound is called as the Dicman cyclization, or the, here I am writing C double bond O, then OET, then here CH2, then CH2, CH2, I am writing this one CH2, then here maybe as a C double bond O, and then OET. Let us see here 1, 2, 3, 4, 5 and 6 over there, right? 6 carbon atoms are there. So this type of the compound 1, 2, 3, 4, 5, n number of if you see here, n number if you give over here, then carbanion can form either this side or this side, and then that will be treated with sodium ethoxide, NaOET, and what is going to happen? The compound you are going to get over here, that is, you can write n number of n number over here, and you may get this one C double bond O, then C double bond O, OET. This type of, this is alpha, this one is a beta, and this is a n number, means that depending upon the number of carbon atoms over there. Now let us look at the mechanism, how the mechanisms are taking place over here. So let us see, we are going to see as a Dicman cyclization. Suppose I am writing here is a this 5 membered ring, C double bond O, then C double bond O, OET, this one. How do I get? If I have a starting compound over here, C double bond O, OET, I am writing this one, then this and this one, 1, 2, 3, 4. Now here I am writing as a hydrogen atom, and then C double bond O, OET, like this, and then OET minus will abstract the proton, form the carbanion over there, and you are going to get the same product, C double bond O, OET over here. This I am writing as it is here, forming as a negative charge, then C double bond O, OET as it is. Now there is a delocalization or the resonating structure, negative charge over there, so that you are going to get here C double bond O, OET, then this minor charge over there, sorry, not minor charge, now is a double bond, the negative charge on the oxygen atom, and OET like this. And in the next step, what is going to happen? This negative charge coming here, forming as a double bond over there, and this double bond is going to attack on this carbonyl group, and this double bond revolving around that carbonyl group, and OET is a good living group, it lived, and so that you are going to get finally 1, 2, 3, 4 and 5 membered ring. You are going to get the product like this, C double bond O, then C double bond O, OET. These product and these are the same. If you take as a 6 membered ring, you can take as a one more additional compound over there. So in this way we can prepare the this is known as a Dicman cyclization. Now if you want to prepare this type of the compound, let me give one more example so that you can understood the Dicman cyclization. Now I am taking 6 membered ring, C double bond O, and then C double bond O, OET over there. So this structure I am representing on the blackboard, that is according to as a zigzag structure, right? Now I have a suppose as a this type of the compound, C double bond OET, then 1, 2, 3, then maybe as 4, 5, double bond O, OET. Now let's see 1, 2, 3, 4, 5 and 6 carbon atom I am choosing over there, and now here is a hydrogen atom I am taking over there, and OET minus, which will abstract the proton, form the carbanion over there. So I am going to get here C double bond OET, then this, then this, then C double bond O minus ET. There is a negative charge, this goes into as a cyclization, so that you are going to get, I am writing for C double bond O, then OET I am writing like this, or for sake of convenience I am writing this one maybe as a C double bond O, this one, this, negative, not negative, double bond O minus, and here OET, here also has a OET. Now 1, 2, 3, 4, 5, and this one is a 6. Now this negative charge coming here forming as a double bond, and this double bond is going to attack on this carbonyl group, and this is revolving around it, and OET is a leaving group, and finally I am going to get the product, that is a desired product I am got over here. This is a alpha and beta, this is a beta keto ester I have got over here. So in this way I think we have completed as a Clausen ester condensation reaction, simple, crossed, and the Dicman cyclization is nothing but as a intramolecular Clausen ester condensation. So next time we will see remaining reactions. So let us stop today here. Have a nice day. Thank you.